All right, so thus far in chapter 3, we've learned a lot of things, okay? We have a lot of ways to talk about data, to summarize the central tendencies, numerically summarize the data, all of that good stuff. But we need to have a nice way that's understood to really explain the best interpretation of these different measurements. Now, standard deviation is still important, but we're not really focusing on that one today. We're going to focus on what's called the 5-number summary. The 5-number summary gives us 5 numbers that represent good measures of spread and central tendency for our data. So let's remember a few things. Remember, median is the measure of the central tendency that divides the lower 50% of the data to the upper 50%. So it's your 50th percentile or second quartile. It is resistant to extreme values and is the preferred measure of central tendency when data are skewed left or right. If it's completely uniform, we would rather use mean or average, but for skewed data, median is better. The 3 measures of dispersion presented in 3.2, which was range, standard deviation, and variance, are not resistant to extreme values. However, the interquartile range, which we learned about the last time we took notes, which is Q3 minus Q1, the difference between 75th and 25th percentile, is resistant. It is interpreted as the range of the middle 50% of the data. However, the median, Q1 and Q3 do not provide information about the extreme values of the data, those outliers. So a 5-number summary is a set of data that consists of the smallest data value, Q1, the median, Q3, and the largest data value. And we literally just list them like it shows you. We would have the minimum value. We will have quartile 1, our median, quartile 3, and our maximum. That is the 5-number summary. So let's just see if we can do this. It says the data shown in table 17 shows the finishing times in minutes of the men in the 60 to 64-year-old age group in a 5-kilometer race. Determine the 5-number summary of the data. So table 17 just gave us, boom, our sample. We then place the sample in ascending order, so in number order, which I will show you in a little bit how to do that on Excel, so that we can quickly figure out the median, which Leah did figure out that there is a command for median on Excel. I didn't know this actually. It's equals median, correct? Yeah.
Equals median, and then you just
drag the cells. Awesome. So we can use Excel for that, equals median. But I have listed them in ascending order for you. So if we go through like we learned on our paper and we just take one off the top and bottom over and over again, not completely marking out the numbers so we can still read it, we're going to see that there is a median value of what? 30.95. So we know our median. We then need to know our quartile 1 and quartile 3. So we need to know basically the median of the bottom 50% and the median of the top 50%. So if we go back and we look at just the median data that's less than 30.95, and I start crossing them off the other way, I guess I'm doing this with highlighter, I see that I have 2 in the middle. So what I will do to find the quartile 1 is I'm going to take these 2 and I'm going to average them together. So I would do 25.83 plus 26.28 divide by 2, and you should get 26.06, yes? If we do that on the other side, and again, we're just finding that Q3, so the median of the top half of the data, we end up with 2 values in the center, so we find the average of those 2, which gives me 37.24. So my 5-number summary, to write it down, we want the minimum value. What's the minimum value? 19.95. We want quartile 1, which is 26.06. We want the median, which is 30.95. We want quartile 3, 37.24. And we want the maximum, 56.62. Boom, 5-number summary. It shows me pretty resistant data values And it would show me some outliers because I have the maximum and minimum. I see it. I see it. So sorry. I don't know what I'm doing. Now, there is a way to get these numbers off of the TI-84 if you have the data there. It is a part of that one variable statistics page. You can find the max, min, quartile 1, median, quartile 2, 3, and all of that stuff. On Excel, you can find each individual piece the way we just talked about it for medians. You could also sort the data so you can see it in ascending order. But that's a very helpful quick summary of the information that we had. We feel good about the 5-number summary. Great. The next thing we're going to work on and spend pretty much the rest of class on is called a box plot. A box plot is the 5-number summary, the visual representation, sorry, I lost my words, of the 5-number summary. Okay, box plot. You need a couple things to draw a box plot. First of all, you need your interquartile range. So we found that to be Q3 minus Q1. Again, we found that using the 5-number summary. So we have Q3 and Q1. We then need that lower and upper fence that we used when we were finding the outliers. The formula for lower fence was the quartile 1 minus 1.5 times the IQR. And the upper fence was quartile 3 plus 1.5 times the IQR. Let's just go ahead and do that much for this problem so we can do it piece by piece. We're constructing a box plot for the numbers that we had on the front page. So for that data from table 17. That means that our IQR will be found to be Q3 minus Q1, which was 37.24 minus 26.06. which is 11.18. That's the interquartile range for our data. The middle 50% of data is 11 units apart from each other. If we go to find our lower fence, we're going to do quartile 1 minus 1.5 times that IQR we just found. So we're going to compute quartile 1, so 26.06 minus 1.5 times 11.18. I trust you to be able to type this in a calculator, so we're going to fast forward. This is 9.29. We compute our upper fence using the other formula. I don't know why I put a P. Upper fence, which is quartile 3 plus 1.5 times that IQR that we found, the interquartile range, which would be 37.24 plus 1.5 times 11.18, which is 54.01. We followed that computation. I know I didn't give you time to actually type it in, but we get it, yes? Theoretically? Once we have these 3 numbers, your IQR, your lower fence, and your upper fence, we're going to go to step 2, which says to draw a number line long enough to include the minimum and maximum values and insert vertical lines at Q1, the median, and Q3. So coloring wise, I've been using green for our quartiles and blue for our median. So here's my number line. I gave you a line but no numbers. What's our lowest number or our minimum value? 19.95. And then our lower fence is what number? 9.25. So we need to make sure our number line goes from either the lowest of the lower fence or the minimum. So honestly, I'm just going to start this at 0 because 9 is not too far off from 0. What's the largest number in my data again? 54.63. And then the upper fence is at 54.01. So I'm just going to make this 60 just to make it easy for myself. So from 0 to 60, which means halfway would be 30. And then if we give this 10 and 20, there's 30, here's 40, here's 50. We're just going to try to make it as best as possible on this number line. And we're going to draw in vertical lines at Q1 the median, and quartile 3. If we think about our data from before, we had a median at 30.95. This is what I'm getting from our front page. So I'm going to go to just tiny little bit above 30, and I'm going to draw a blue vertical line because that's my median. 30.95 median. Don't need these numbers, but these are our notes so we remember what we're doing. We also want to draw on a vertical line at quartile 1, which is at 26.06. So 26.06 would be here-ish. 26.06, this is quartile 1. Quartile 3 is at 37.24. So again, just do your best to estimate that. 37.24, that's quartile 3. Check, check, check. I've drawn vertical lines. It then goes on to say, enclose these vertical lines in a box. Okay, I've enclosed these vertical lines in a box. Thus, box plot. Yeah, okay. It says then to label the lower and upper fences. So I'm going to take the lower fence of 9.29 and I'm going to draw like a little bracket. This is the lower fence of 9.29. Then I'm going to draw in the upper fence, which we found to be 54.01. This is the upper fence. Step 4 says to draw a line from quartile 1, that's my green line, to the smallest data value that is larger than the lower fence. What was our minimum value here? 19.95, right? So I'm going to go to 19.95 and I'm going to put a little dash right there. This is 19.95. That's my minimum. And I'm going to connect the dots. This is the whisker of the box plot. These are also called box and whisker plots sometimes. We're going to do the same thing on the other side. Draw a line from Q3 to the largest data value that is smaller than the upper fence. So what was our maximum value? 54.63. Is that smaller than my upper fence? No. So look back at the data. What is the next largest value? 49.17 is what I'm going to put in here. So here's 49.17. We go there. It is the next largest value since my actual maximum was outside of the upper fence. Any data values that are less than the lower fence here or greater than the upper fence here are outliers and are marked with an asterisk. So we had this value here, no? That was 54.63. Since that little asterisk is outside of the upper fence, it is an outlier for my data. So a box and whisker plot not only allows me to summarize pretty much the 5-number summary, minimum, Q1, median, Q3, maximum, I also can see immediately that we have an outlier in our data because we calculated the IQR and know our lower and upper fences. A lot of times, I'm not going to erase it on my actual notes, like I'm going to put them back in a second, but a lot of times the box and whisker plot will not actually show these upper and lower fences, so it's going to look something more like this. But when we're drawing them ourselves, we need those lower and upper fences to determine if we have an outlier. So a summarized version, done, 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 won't have those lines there. But because we're using this to learn and I want to make sure we can look back later and remember what we were doing, I will leave the lower and the upper fence there. Now that's a lot of work, huh? Let's make technology work for us. So what we're going to do is we're going to go to Excel. And now that you have your nice number pads and your mice, this might be easier. We're going to type in all of that data. It does not need to be in number order because we can sort it real fast. So in fact, to teach you how to do that, I want everybody to type table 17, not the ascending order version, but table 17 from the notes. There's some interesting things I want you to know, and I'm realizing that we don't have a ton of skills on Excel yet. There is a way to sort this data to put it in ascending order. Watch up at the screen for a second. I'm going to highlight with my mouse all 21 cells, and I'm going to come over here where it says sort and filter, and you can sort it from smallest to largest. And so boom, it's going to reorder everything in smallest to largest. So you don't have to sit here when you're doing median and do that. In fact, like Leah said, we can do the equals median, open parentheses, and then select all that data, close parentheses, and it will tell you the median value. Before we went to lunch, what we were doing was looking at the data. That was the median. I'm going to go ahead and delete it so I only have the 21 values that I want to make the box plot for, because remember, that's what we were actually doing on Excel. To do this, we're going to follow the instructions that are written in your notes, which say enter the raw data into column A. Check, we did that. Highlight the data, so you're going to select the entire array of cells, and you're going to go over to insert. So insert. And then you're going to look at the charts. You specifically want on the bar charts area. It's called a box and whisper on Excel. So you select box and whisker, and it's going to give you that value. So if you notice, we had this lower value and our upper value, and then we have our outlier. Okay, so it does do it vertically, which is kind of weird. I don't know why, and I played a little bit to try to get it to be sideways like ours, but I couldn't quite figure it out. I know that there's a way to do it, so if anybody can figure it out, let me know. But it is a vertical box and whisker plot as opposed to our horizontal ones. So why a box plot? What does it tell us? Thank you so much for asking. That's a really great question. When we're looking at a box plot, the histogram that goes with it will tell us a lot of information. So if we have a bunch of information that's skewed to the right, you'll see that the box plot is also got a longer tail on the right side. So we have our, if we follow our color coding, we have still our median, and then we have our quartiles, and then we would have our maximum and minimum inside the upper and lower fence. If it's uniform, everything's going to be straight up in the center. We will have the median, our quartile 1 and 3, and again, the whiskers on the side will be pretty much uniform, if that's a symmetric bell curve. If we're skewed to the left, that means we have a longer tail or whisker on the left side of the box plot, but we still have Q1 and Q3 and your median there in your center. So it's nice to see box plots because it does give us a lot of information if we know the values of those different portions about the actual distribution of the data, whether it's skewed to the right or to the left or uniform. So what we're going to do in this last question, in example 4, is we are going to create 2 box plots at the same time to compare the different distributions together. Let's go ahead and use, we're going to write a lot of it down on our notes, but let's go ahead and use Excel to find all of the things that we need just for good practice. Is that cool with everybody? So here we go. I'm going to switch over to Excel. Just so you know what I'm doing, I'm going to type first all of the flight data and all of the control data as 2 separate columns. In fact, maybe separate them by a blank column in between so that we can have that data in Excel. Once we found all of these things on Excel, let's just write down on our notes what we found. Let me pull this over here so you can see what I'm doing. So we found out that for the flight, that the minimum value is how much? 6.39. The quartile 1 was 7.00. Our median was 7.715. Quartile 3 was 8.64. And our maximum is 9.79. I have my 5-number summary. The things we're going to need also with this data is the IQR for the flight, interquartile range, which means I'm taking quartile 3 and subtracting quartile 1, which would give me 1.64. The reason I want that is because I want to make a lower and an upper fence for both of these. The lower fence will be quartile 1 minus 1.5 times the IQR, which is 1.64. What am I writing? Oh my goodness. Either way, however you calculate it by hand or with Excel, you get that the lower fence is 4.54 and the upper fence is 11.10. Okay, this is all for the flight information. So what we can do back on our paper, which I know, again, we can use technology to do this on our computers, but we can by hand draw the box plot for flight. I'm going to have you draw both on this one timeline. We're going to do the flight above timeline, oh my gosh, number line, and we'll do control underneath it. I'm going to have you guys do control later. When we did this earlier, we had to make a number line that would fit all the data. Bless you. Our lowest value would be a little bit more than 6, and we'll go all the way to 12 just for good measure because that's easy to count. Between 6 and 12 is 9, so this would be 7 and 8, 10 and 11. We said that our median for the rats that were on the flight was 7.715, so that would be here-ish. That's our median number. Our quartile 1 is 7 flat, and our quartile 3 is 8.64. So we have our box. Our lower fence is 4 point something, so it goes off screen. And our upper fence, bless you, is 11.10. But my lowest value on flight itself is 6.39. And the highest value is 9.79. So there are no outliers for this data. I only did half this problem because our goal is to compare the two sets of data by looking at Boxplots at the same time. So now I want you to look at the control data, which you probably already have typed in your computer, and I want you to find me all of the same things. I will put a video online at your request of me working through the Excel for all of this. I'll do it during 4th period, so be looking for that. Right now, we all can hear me talking to myself. Kind of weird. I'll do it during 4th period.
You do that all the time, I know.
True, but y'all are here to, you're not like listening. I don't know.
Well, we are listening.
Maybe I will do it now. Anyways, it'll be a separate video that you can go watch. That's the end of chapter 3. Your chapter 3 test is next time. I'm going to give you a fresh Excel document that you're turning in with your test.
Oh, ew.
So instead of scratch paper, I shall still give you a scratch paper as per usual. I will also give you a scratch Excel to turn in at the end of the test.
Friday?
On Friday.
Oh, I gotta test them all.
So I recommend putting all of those formulas from this whole chapter on that front page so you're prepared. Maybe some Excel shortcuts for yourself. You're getting a blank Excel and then the test. Okay.